Welcome, everyone, to the UWS-CCT's Research Podcast. We're part of the University of the West of Scotland's Creative Computing Technologies Research Group. And today we're looking at something really fascinating. It's about how cultural heritage institutions, museums and archives, are using web-based 3D tech, Web3D, to put their collections online. It basically brings history right into our homes.
It's incredibly powerful stuff. Suddenly, artifacts aren't locked away. You can explore them digitally from anywhere.
Exactly. But there's a catch, isn't there? A big one we're exploring today is accessibility.
That's right. While Web3D is amazing, it creates some serious challenges, especially for people who have difficulties with, say, upper body movement or using their hands precisely.
Yeah, think about how you usually spin a 3D model online. Clicking, dragging, maybe keyboard shortcuts. That's just not feasible for a lot of people.
And we're not talking about a small number here. The World Health Organization figures are quite sobering. They estimate about 2.5 billion people globally need some kind of assistive technology right now.
2.5 billion. Wow.
Yes, and that's projected to hit 3.5 billion by 2050. And if you look at specific countries like the UK, it's around 24% of people with a disability. Nearly half of those report mobility issues, and a quarter have dexterity challenges.
In the U.S.?
Similar picture, around 27% with a disability, and over 12% of adults specifically mention mobility impairment.
So hundreds of millions worldwide could potentially be excluded from accessing all this rich cultural heritage online if we don't get the accessibility right from the start.
Precisely. It's about equity, really, ensuring everyone gets a chance to engage regardless of physical ability. There's a definite gap in making these really immersive Web3D experiences usable for this huge group.
And tackling that specific gap is exactly what the research we're digging into today is all about. We're looking at a paper titled Enhancing Web3D Accessibility in Cultural Heritage, an eye-controlled 3D model viewer.
That's the one. The authors are Julius Bernikas, Raymond Holder, Thanos Kokkiniotis, and Marco Gilardi.
And what they've done essentially is present work on a 3D viewer designed specifically to help people with those upper body impairments interact using their eyes.
Yeah, using eye tracking. It directly tackles that barrier of needing a mouse or complex keyboard inputs for Web3D. That's the core idea here.
Okay, so let's unpack this. We need to understand the problem they're solving more deeply, how this eye-controlled viewer actually works, and what kind of impact it could have.
Well, a key thing to note first is their approach. They used what's called human-centered design.
Human-centered. So not just engineers in a lab, right? They worked with actual users or institutions.
Exactly. They collaborated closely with Smartify Holdings Ltd. And, crucially, a major cultural heritage institution. The whole point was to understand the real needs, both from the user perspective and what the institutions require. It was iterative, so they got feedback and refined things along the way.
Okay, that makes sense. And the software itself, the viewer, how is it built to be flexible?
They designed it as a kind of templated system. Think of it like a framework where an institution can slot in their own exhibit, their 3D model, relatively easily.
How easily? Like, do you need to be a coding whiz?
No, that's the neat part. It's configured using a simple JSON file. That's just a standard text format. So the institution can edit that file to specify the model, the user interface elements, what inputs do what.
Okay, so they can tailor it without deep programming knowledge. That's smart.
Very much so. And it makes it adaptable for different kinds of assistive tech down the line. At its core, the viewer uses WebGL for the 3D rendering that handles showing the model the basic rotate, zoom, pan functions.
Right, the standard 3D stuff. But making that accessible without a mouse or keyboard, that's the challenge. How does the eye tracking actually control it?
That's where the UI module, the user interface, comes in. And this is a really clever bit, I think. Traditional 3D viewers often bury navigation controls behind, holding down a key while dragging the mouse or complex key combinations.
Like shift plus arrow keys or right click and drag. Things that are impossible if you can't perform those actions easily.
Exactly. If you look at popular viewers, say Smithsonian Voyager or Sketchfab, they're great. But the main ways you navigate rely heavily on those traditional inputs. Voyager uses those key combos. Sketchfab needs mouse gestures.
Okay, so this paper's approach is different because
they don't rely on those hidden gestures. They take the core actions, rotate left, rotate right, zoom in, zoom out, pan up, down, etc., and they make them explicit buttons on the screen.
So the controls are visible, always there.
Yes, usually in the corners on the desktop version. This keeps the main view of the object clear, but the controls are persistent and, importantly, targetable by something like an eye tracker.
I see. So the eye tracker interacts with these on-screen buttons. How did they actually test if that worked?
They used a Tobii Eye Tracker 4C for their tests. The user would look at a specific button, say the rotate left button, and then use a simple switch, like pressing the spacebar in their setup, to trigger the click on that button.
So your eyes select the action, and a simple single input performs the click.
Precisely that. And they confirmed it worked. They could navigate the 3D model just using eye gaze on the UI buttons and that single switch input. It proves the concept for users with those upper body impairments.
That really does sound like a breakthrough for this kind of interaction. Did they build in any other accessibility features?
Yes, they considered other aspects too. For instance, pop-up labels appear when your gaze rests on a button explaining what it does. They also added ARIA labels to icons and some other elements.
ARIA, remind us quickly.
Sure. ARIA stands for Accessible Rich Internet Applications, and WCAG is the Web Content Accessibility Guidelines. They're standards meant to make web stuff more accessible, especially for people using screen readers or navigating only by keyboard. Applying them perfectly to complex 3D is still tricky, as the paper acknowledges, but they integrated them where they could, like ensuring screen readers could announce the title and help text.
Okay, so thinking broadly, but the main innovation here for the mobility challenge is definitely exposing those navigation functions as simple UI buttons that eye tracking can hit.
Exactly. That's the fundamental shift compared to most viewers. It makes integrating assistive tech like eye tracking much more straightforward because you're not trying to emulate complex simultaneous mouse and keyboard actions.
It feels like they fundamentally rethought how you interact with the 3D object, breaking it down into discrete steps compatible with single-point inputs.
That's a good way of putting it. They saw the limitations in existing frameworks and built something specifically to bridge that interaction gap.
And did it get used? Did that cultural institution they partnered with actually deploy this viewer?
Yes. The paper mentions it was successfully used by the institution as a live Web3D application. Apparently, since it went live, it had been accessed over 2,000 times through their website. They even had plans for on-site QR code access.
2,000 times. That's real validation, isn't it? Shows there's a genuine need, and this approach works in practice.
It certainly does. But the authors are quite clear this is still work in progress. They've identified areas for future work.
Okay, like what? What's next for it?
Well, they want to refine the button placement and size based on more user feedback, make it even easier to use. They also plan to integrate things like 3D annotations, points of interest on the model with the eye tracking control.
Makes sense. What about mobile? Does the eye control work on phones or tablets?
Not yet. The eye tracking features they implemented were for the desktop version. Mobile has other aspects, like augmented reality features in their viewer, but adapting the eye tracking for mobile is listed as a future step.
Right. Different interaction paradigms there.
And they also stress the need to explore support for other assistive technologies beyond just eye tracking and a single switch, maybe head movements, different adaptive buttons. And crucially, they point out that while it's technically working, they need proper user studies with people who actually have these upper body mobility or dexterity impairments.
Ah, yes. To get that direct feedback on usability, find any pain points.
Exactly. That feedback loop is vital to ensure it truly meets the needs it's designed for. Their bigger vision is to contribute towards a more comprehensive accessibility framework for Web3D generally.
Okay, so let's just sort of pull this together. We have Web3D offering amazing ways to see cultural heritage online, but traditional mouse and keyboard controls lock out millions.
Yeah, huge number of people.
But this paper by Julius Bernikas and colleagues offers a really practical solution, an eye-controlled 3D viewer. The key is that clever UI design, turning complex navigation into simple button presses activated by looking and a simple click.
It's a significant step. It starts to make this digital heritage accessible to that vast and growing group needing assistive tech. Those WHO numbers really drive that home, and the fact it's been deployed and used shows it's not just theoretical.
It really highlights how focusing on specific accessibility needs can unlock these digital worlds for so many. It makes you think, this isn't just a nice-to-have feature anymore, is it? For cultural institutions wanting to share collections fairly, it seems essential.
Absolutely. It really should encourage more work in this whole area of Web3D accessibility. It's vital.
And it does make you wonder, as our online lives get more interactive, more immersive, think about virtual reality, other complex interfaces. This kind of thinking about accessibility has to be fundamental, right? Not an afterthought.
Which leads to a question for you, the listener, to think about. As these kinds of rich digital experiences become more widespread, What other areas of online interaction beyond museums and heritage do you think could really benefit from accessibility solutions like eye-controlled interfaces or similar ways of adapting control?
Something definitely worth considering. Thank you for joining us today as we explored this important work on enhancing Web3D accessibility.